See, so this core rod, which is the core rod, here it is that it has two things. First one, it will carry the welding current. Means that the electrode holder is fixed with the positive polarity. So the current from the positive polarity moves around from the electrode holder to the electrode. You can hold the electrode rod, it is insulated. So from the electrode rod, it is taken to the electrode. Second one, it became the part of the weld. Means that the electrode is going to melt or it get consumed or will be deposited on the welded area. So these are the two things. Second one is flux coated. This flux coated, keep in mind, in any mechanical process, if the flux comes into the picture, there will be slag. If the flux comes into the picture, we will get slag. Means that another example is that if you see casting, in casting process, they will mix flux in order to avoid the impurities, or in order to remove the impurities, they will add flux. Flux is nothing but the calcium powders. Okay. For the furnace, they will wantonly add the flux. Okay, the flux will create this slag. That means impurities which will go and float on the top of the area. So before pouring into the ladle, they will remove the flux. Right? In the furnace, before pouring into the ladle, they will have a small, big, removing pan like something. So that it will be means that it looks like paladam solvaanga illaya. So we will take it out. So same way we have a flux coating. So in any mechanical process, if flux comes into the picture, we have a slag as this byproduct. So flux and the slag. So the first one is it will provide the shielding gas. Means that it will provide the shielding gas. So this shielding gas will float like this. Shielding gas will float like this. Means that this shielding gas will be like a gloves over our hand. So it will avoid the outer atmospheric air to contact on this welding area. Which means that the outer moisture or outer impurities cannot be touched on the it will protect the welding area from the outer atmospheric impurities. Second one is that it will act as an additional filler area. It will act as an additional filler. Okay. The third one is that it forms the slag. It forms the slag. So this slag, okay, if you do the welding process, I will show you a video. If you do the welding process, the slag will get melted over. It will get floated over the area. Like furnace is like a furnace. In furnace, the main difference between the furnace and this type of welding, this type of heating is that furnace it takes a very long time to get heated. In a very long time it will be the heating process, or the heat will be there. In welding, the heating and cooling takes place at the fraction. Heating and this slag creation process will take it in a fraction of a second. This happens mainly because of the welding power. So the weld power of this particular SMAW comes around 5000 degrees Celsius. So the fraction of a second, if you want to create the 5000 degrees, if we create 5000 degrees for a fraction of a second, then only you can melt the electrode, which is has the melting point of around 1000 degrees Celsius. So for the fraction of a second, we have to create a 5000 degrees Celsius as a welding power. So this weld power helps to melt the electrode, which has the melting point around 1000 degrees Celsius. So the first one is shielding gas, as I already said. The second one is the slag process. So you can see this is the slag area, this is the slag unremoved slag area, this is slag removed area. You can see this is a T-joint. You can see this. So here the slag removal process is very simple. What they will do is, after welding, they will take the chipping hammer and the wire brush to remove the slag. If the slag is not removed, the main thing is that it will deteriorate the quality of the weld. The another mistake what raw material students will do that before removing the slag, they will go on they will wash their workpieces before removing the slag. Other times the slag will get hardened, so it is very hard to remove it. So if it is not removed, you cannot directly use this piece on the main application. Okay, so this is the part. So why we are using SMAW as the in many areas is that it is very less complex. Means that if you have a three-phase current, if you have current, we can move. We have to do this welding process anywhere. We can do it in the underwater. We are going to do in the desert area. The main thing is that we need current. That's all. This is the only part. So most of the many metals will have an electrode in the SMAW welding process. Means that in many welding process we don't get a proper electrode. But in SMAW it's quite easier to get the welding electrodes which is similar to the workpiece. So we can easily match the properties and we can easily do the welding. The main thing is that it cannot be used on the soft metals. like gold or aluminum, silver, sorry, gold or silver are very soft materials, we cannot use the SMLD process. Yeah, it means low melting point, and sometimes their thickness is very low. It's heat